Okay, we're back, and we're building a Chip-8 emulator, which isn't really an emulator, because Chip-8 doesn't actually have hardware. It's a virtual machine, but I digress. It'll be fun. So we are stuck right now at the opcode that displays sprites, and we're just going to give it a shot. So case OXD000 displays the n byte sprite starting at memory location I at VX VY. So VX stores the X position, VY stores the Y position. And so what we'll do is we'll do something like this. Int X is equal to V, and we're going to get the VX, which is that chunk right there. And then we'll get int Y is equal to V, something similar to this, but the next little nibble, shifted by 4. So now we've got the X and Y position, and then we're going to write n lines of it. We'll just grab that last section of the opcode. Okay, so now we've got X, Y, and N, and we need to go and get that from memory. And then we need to loop over each of the bits in those bytes and map them into our display array. Should be no problem. For int I equals 0, I is less than n, I plus plus, we're looping over each of the rows, and then I imagine that every row we're going to increment y. Seems fair. So display x, we're going to be looping over we're going to be looping over 8 values here, because there's 8 bits in a byte, and the byte that we're going to be drawing is equal to our memory, which is our RAM, I guess, indexed by location I. And then what we'll do is we'll do something like, let's see, what's the best thing to do here? Well, we're going to have to get whether or not we set it, first of all. So byte set is equal to mem shifted by, and let's just see what order they're storing these in. So that's 1, 2, 3, 4, and then 0, 0, 0, 0. Cool. So it is left to right. Okay. So the MSB is actually the left value. And so we're going to be, if I'm moving from x equals 0 across, then I need to get the MSB first. And so I'll shift this by 7 minus j. So that will start with the MSB because it's shifted by 7. And I'm going to end that with OXO1 so that I only get 1 bit at a time. And I think that's all I need. And I'll cast that to byte. Cool, so that's going to be my, let's just call that pixel, perhaps. And then what I can do is I can say if, and let's see what that display did. Sprites are XORed if this causes any pixels to be erased, VF is set to 1. So any pixels, VF is set to 1. Otherwise set to 0. So what we're going to do is right at the start, we're going to set it equals to 0. And then if any of these pixels, when XORed with the display, causes it to flip back to 0, we'll set V15 to 1. Perfect. So if pixel equals 1 and then display at the position we're writing, which is going to be x plus j, let's do this right, so that's the x value, plus whatever y position we're at, plus I times however many pixels there are per row, and I think we were 64 pixels per row. Does that sound right? 64 pixels per row. Okay, so this is our display index. I'm actually going to store that somewhere. Index is equal to that big chunk of stuff. If display index, so if, let's just say if pixel equals 1 and display index equals 1, then V15 is equal to 1. So that means we are going to be flipping the display back to 0. And then we can say that display index is equal to display index XORed with pixel. And then we just have to convert that back to a byte. Cool. And then I think that's it. X plus J, that's going to loop over the 8 values. Y plus I, so that's going to be each of the rows times 64, and this will correctly wrap around to the start as well. So I think we're in good shape. Cool. Let's go to the next opcode. EX9E. What's up with these? Why such randomly specific instructions? Okay. Case OXE000. Okay. If the opcodes last byte, I guess, is equal to OX009E, then we're gonna do something. Else, if that same stuff is equal to OX00A1, then we'll do something. Else, we'll throw that exception saying we have no idea how to deal with that. Okay, so 009E. Skip VX. Skip the next instruction if key with the value of VX is pressed. Okay, so we're gonna have to get something from the console, I guess. Console.read key. What does that even return? What does read return? Let's just try that. Var key is equal to this thing. That thing's a console key info. I don't even know what console.key. Key car? That looks nice. I can understand that. And it had 16 buttons. What has 16 buttons? I'm trying to think of how I can map this to a keyboard. I'm gonna cheat. I'm just gonna say, I'm gonna read from the console an entire line, and I'm gonna try to parse that as an integer so that I can type values like 15 and then just use that. So I'll get a string from the console, and then if try parse. So we'll write some console.writeLine, enter a value, for example. Console.readLine, if int try parse line out int value. Else we can throw new exception, unexpected keyboard input. And then what we'll do is we will skip the next instruction if key with the value VX is pressed. So if the value is equal to the opcode ended with OX0F00 shifted by 8. Skip the next instruction if the key with that value is pressed. PC plus equals 2. Okay, and then all of this is the same sort of deal. But it does not equal, so if the value equal is not pressed. Checks keyboard, the corresponding value of VX is currently in the up position. Right. Wants to know if it's held. Awkward. So I need to have an array of 16 booleans and check to see if those values are held or not. Okay, we can do this. Keyboard. What was I using that for? Wikipedia had something about a keyboard here. Keyboard has 16 keys. Okay, that's what I'll use. Alright, we're going to try this one more time. We're not entering a value anymore. We are going to say if value, or if keyboard shifted by that thing. And with OX01 is equal to OX01, then PC plus equals 2. So if that value is held down, we don't increment it. Need to worry about order of operations again. Do the same thing here, but it does not equal OX01. Okay, I think we're good now. We'll just have to have some way of updating this keyboard value as we play. And figure out what keys I'm going to use. What on the keyboard has 16 buttons? It's so awkward. What is the QWERTY thing? 1, 2, 3, 4, 5, 6, like 10? Huh, okay. Where are we at now? We're at setting delay timers, okay. Case OX F000. So we've got F00A, F015, F018, and F01E, and F029. There's quite a few, and they all work on the last byte. And so what I'll do is I'll switch on the opcode ended with OX00FF, so I get just the last byte. And let's see, what do they use? It looks like they mostly use VX again. And do they ever use VY? No, it's just X. So I'm going to go and get that value here, so I don't have to have this code littered throughout my switch statement. I'll just call it VX. I already used VX somewhere. It's annoying. Where do I use it? Yeah, I use it up there as the index to it. Okay, I'll just call it V then. Lowercase v. And what's my first one here? FX07, case OX07. Set VX equals to the delay timer value. Okay, so I do actually want that chunk of it. I don't actually want the contents of VX. So this is going to be V. That'd be nice if I could just use that. What I'm going to do is I don't want it to be a total hack. I'll call it TX. Where are we here? This is OX07, OX07, VTX is equal to the delay timer value. Okay, OX0A, wait for a key press and store the value of the key in VX. Okay. Wait for a key press. So I need to be able to say that I'm waiting for a key press, I guess, and just sit there waiting for somebody to press something. So public bool waiting for a key press. And we'll just say waiting for key press equals true. And then at the top of this here, we'll have if waiting for key press, we'll do something. Wait for key press, store the value of the key in VX. All execution stops until the key is pressed, and the value of that key is stored in VX. Waiting for key press. This is starting to look like a little bit of a hack. Execute opcode. Okay, I'm going to have something here called step. And this is what's actually going to run my loop, I think. How do I want to do this? Waiting for key press. If waiting for key press. See, yeah, this is waiting for key press. I guess I should have that opcode there. So I'll return from this, and then I will say V of opcode ended with OX0F00, by 8 is equal to whatever the keyboard was. Now return. That's kind of a hack for now, but I think it will kind of do the trick. So x15 dt is set equal to the value of vx. So delay timer is equal to vtx. For case ox18, sound timer is equal to vtx. ox1e sets I equals I plus vx. I plus vtx. ox29. So we need to convert this back to u short. Set I equals the location of sprite for digit vx. The value of I is set to location for the hexadecimal sprite corresponding to the value of vx. See section 2.4. Okay, so this is the built-in hex font. Set I equals location of sprite for digit vx. Okay, let's take a quick look at this. These sprites are 5 bytes long, so each of them is 5 bytes long. If each of them is 5 bytes long, then we can really just multiply the value of vtx by 5, right? I is equal to u short of vtx times 5. Because if that is 0 and it wants to point to 0, then it shows 0. If it's 1, then we want to be indexing 5. I think that should be just fine. Okay, so 29, we've got ox33. Store the BCD, is that a binary coded decimal? No, it's definitely not BCD travel. Binary coded decimal. Really? Decimal numbers. Huh. Full byte of each digit. Exciting. What does it say about this? Store a BCD representation of the x in memory locations I plus 1, I plus 2. The interpreter takes the decimal value vx and places the hundreds digit in memory at location I, tens digit location I plus 1, and the ones digit at location I plus 2. Okay, we can figure that out. So I guess that's going to be my RAM. I is equal to VTX divided by 100. And these are all bytes, right? Yeah. And then RAM I plus 1 is going to be the tens. So that's VTX mod 100, so that I only have the tens and ones left. Oops. Divide that by 10. And then finally RAM I plus 2 is equal to byte VTX mod 10. So we just have the ones left. I think that's it. Cool. Okay, so we did tree 3. Store registers V0 through Vx in memory starting at location I. Okay, so case OX55. So we need to loop over all 16 values of V. And we're going to set RAM I plus I is equal to VI. Oh, store registers V0 through Vx. So it's through VTX. So that one. VTX. Registers V0 through Vx. That's... I think it's actually to TX, isn't it? That's what they're trying to say. Let's compare that against the Wikipedia version. 5.5. Stores v0 to vx, including vx in memory. Including vx. During address I, the offset form is increased by 1 for each value written, but I itself is left unmodified. Yep, sounds good. The last one, OX65. Read registers v0 through vx from memory starting location I. Equals 0, I is less than or equal to tx. I plus plus. vi is equal to ram I plus I. And then default is that we don't know how to do it. That's all the instructions. I think we've got them pretty much all. What's complaining about here? vtx times 5, I've got square brackets in there. Fix that. Let's run it and see what opcodes are missing. A bunch of 00s, some FFs. Okay, we'll start to deal with these once we're back.